Hello. On this video, we're going to practice some gram to mole conversions and also review just a little bit on how to find molar mass on there. So on this problem, it does say find the number of moles is going to be our first part here. And so the very first thing that you need to do what I call a gram to mole conversion is you must find the molar mass. So we're going to find the mass for phosphoric acid. Anything that starts with an H is an acid, so this is phosphoric acid. So we're going to just do a count real quick. I have 3 hydrogens. Again, we're going to use the same periodic table. And so the mass of hydrogen is going to be 1.01. We have 1 phosphorus, and its mass is 30.97. And we have 4 oxygens, which has a mass of 16. Okay, so this is how I set it up. You can kind of choose how you want to set it up. So 3 times 3.01, I can do that in my head. 1 times that I can do in my head. And 4 times 16 is 64. And then add that all up. And again, check my math because I did that in my head, but I believe that's 98. Now, again, you can label this as atomic mass units, but our preference from pretty much here on out for what we do is we want to label it 98 grams per mole, or when we go to use it in our conversion, 0.00, or we want to, when we put it in our conversions, do 98 grams per 1 mole. Okay, so this is where you're going to probably want to write it the most because, again, we'll be unit using conversion. If it's just a label, just grams per mole that way. Okay, so let's come up to our problem here. And our problem is we have 30 grams of that, and we want to go to moles. So we write down what we're given, our 30 grams. Again, put your labels on there. And then, since I have grams in the numerator here, I'm going to go grams in the denominator. And it is always, since I'm going to moles, 1 mole. And then I just come back over here and I get my mass that I just calculated on there. So when you're looking at this and we're doing unit conversions, okay, what I have in the numerator went into the denominator. So you see how these will cancel out with each other. And I'm left with then as an answer of moles of phosphoric acid. So the rest of it is just a multiplication. I'll go ahead and do this one for you. So we're just going to multiply across. If you want to put a 1 here and do that, again, if you feel more comfortable setting it up into your railroad tracks, that's great too. So I will leave that piece for you to decide how you want to set it up. So we have the 30 divided by the 98. And so in this case, I get 0.3061. I'm going to have 4 digits here. I have 4 digits here, but typically we'll just kind of go with the value. Here is pretty much what we're going to go with. So I need 4 digits. That would be 0.3061 moles. And that would be my final answer. Okay. Grams and grams cancel, moles on top. If I start with moles now, this will be flipped upside down. Let's do another one. So I have 25 grams. This would be fluoric acid on there. So again, I come over to the side, hydrogen and fluorine. I have 1 hydrogen and 1 fluorine. And this is the part that sometimes makes these a little long. So after a while, then it may be that the mass is given to you so that you don't have to calculate it. So I had one of each, so no multiplication, so 20.01, and again, grams per mole on that. So I'm going to come over here. I'll go ahead and set up it as a railroad track for you guys. And so again, the grams, 20.01 grams for 1 mole. Okay. My grams are going to cancel of my hydrofluoric acid. Again, cancel that whole thing. And then now I'm just going to do my calculations. And since I'm using my side over here, I don't have any extra room. So I'm going to go this way. So I have 1.25. I have 3 digits and 4. So 3 is what I'm going to go with. So 1.25 moles of hydrofluoric acid. Okay. So we're going to go ahead and try a few in the other direction then. Okay, so I'm on problem number 9. This one, we have moles, and again, I'm going to grams on this. So convert, there's really not, convert, C-O-N-V-E-R-T, to grams. There's not really any difference there in the labeling or the instructions, so I'll go ahead and put that in there. So again, we're going to come over to the side, and I have copper, 1 of those. I have carbon, 2 of those. Be sure you count correctly. Nitrogen, I have 2 of those. Again, let's go to my periodic table and look those up. So I have copper is 63.55 times 1. It's just going to give me 63.55. Table out of the way. Carbon is 12.01. I have 2 of those, so 24.02. Nitrogen is 14.01. I have 2 of those, so 28.02. Again, let's add that up. 9 and 5, 15, 11. Okay, 115.59, again, grams per mole. Sorry, my paper's catching on stuff. So grams per mole. Okay, let's go to our problem then. So I have 4 moles. And again, get in the habit. I know it's a pain and extra work, it seems like, to put your labels on there, but you do have to do that. So moles is here, so now I'm going to put 1 mole. And again, remember the 1 is always with the mole in your conversion. 1 mole of copper cyanide is 115.59 grams. Okay, again, here is my unit cancellations, and the rest is calculations. So we're just going to, in this case, do a multiplication of 4 times the 115.59. So 462.36. Now, when I put that in there, I only have 3 digits there, so I really only need 3 digits. So I'm going to go with 462 grams of copper cyanide as a final answer. So be sure, and if you had already done that, you might not have written the previous there. So that would be my final answer, 462 grams of copper cyanide. Okay, let's do another one here. So this is number 10. Again, I'm going to come over and do a count. So I have carbon, I have hydrogen, I have 6 of each. So carbon, we used in our previous problem, it is 12.01 times 6 would make it 72.06. Hydrogen is 1.01 times 6 would be 6.06. Again, add those up. And so we have 78.12 grams per mole. So let's go back to our problem. So I have 5.600 moles. Okay. And let's see, that'd be hexane or hexene. Not sure which one right off without thinking about it. But again, moles. So we have the 1 mole. It's going to go in the denominator. And your mass goes on the top. Okay. Unit cancellations. The rest, again, is calculating. Now watch here. I've got 4 here. I've got 4 here. This time I'm going to have 4 digits in my answer. And so it's 437.5 grams. Again, guys, be sure you always try to make sense of your answer, because if 1 mole was 78, almost 80, and I have almost 6 moles, so 80 times 6 would be 480. So I should know that that answer should be less than 480 because I rounded up on both of those. Okay, so make sure you make sense of it. Again, guys, the rules is, if I'm going from grams to moles, the grams is going to be in your denominator, your moles is going to be in your numerator. If you are going from moles to grams, we're just going to flip upside down our molar mass so that your grams is in the numerator, your moles is in the denominator. Okay, hopefully that helps you out and you can get some done.